Hello my dear students, I welcome you all for SVK tutorials. In this video I am going to discuss on solution of model question paper 2 of Calculus and Differential Equation. Subject code is 21MAT11. I feel that unfortunately if I would have done this video earlier, it would have been help you a lot, since while solving the problems, while writing the solution for this model question paper, I thought that this question paper is quite difficult. So kindly concentrate on this question paper. Go thoroughly of this questions, all the questions. Okay, continue with the discussion of the questions. As same as we are going to have 5 modules. Each module carries 2 questions. Here the question number 1A, 1B, 1C carries all the questions of A, B, C carries 6, 7, 7 marks. The marks distribution will be like this: 6, 7, 7 marks. And one thing important note I want to tell: don't study self-study part in your syllabus. Whatever the self-study part is there, don't study that part. So question number 1A is on with usual notation, prove that rho equal to 1 plus y1 square whole power 3 by 2 divided by y2. Which is a simple proof on Cartesian form. You are required to find the radius of curvature in Cartesian form, which has been discussed in the previous video. So the content has been already given. So I am going to give the link in the description. Go through that link and thoroughly go through this derivation. So next, if I go with question number 1B, find the angle between curves. Given curves are r equal to a log theta and r equal to a by log theta. It is quite a very important problem. Repeatedly they have been asked in the examination. So consider the two curves. I am going to take log on both the side and apply laws of logarithm on the right hand side, and then I am going to have differentiated with respect to theta. I got this values 1 over r dr by d theta, and the right hand side is, see here, derivative of log a is constant, as it is a constant term, so it is 0, plus derivative of log theta is 1 by log theta into derivative of log theta is 1 by theta. So therefore I left out with the left hand side as cot phi 1, which is equal to the right hand side as 1 over theta log theta. So for my convenient, I will make sure that it has tan phi 1 equal to theta log theta. Similarly, I am going to find out tan phi 2 equal to minus theta log theta. So I have discussed in the previous video, we can find the angle between two curves by considering tan phi 1 into tan phi 2, or else you can consider tan of phi 1 minus tan of phi 1 minus phi 2 is equal to, you know the formula of tan phi angle between two curves, tan phi 1 minus tan phi 2 divided by 1 minus tan A tan B. So like that, using that formula, I got tan of phi 1 minus phi 2 as 2 theta log theta divided by 1 minus theta log theta the whole square. So by simplification, means solving these two curves, I will get the value of log theta, theta value. Substituting that theta value, I am going to get 2e by 1 minus e square. I have substituted the theta value. Theta value is what here? E theta equal to e. So substituting that 2e by 1 minus e square. So taking tan inverse of 2e by 1 minus e square is nothing but 2 tan inverse e. This is the angle between the given two curves. Next, prove that, go through question number 1c. Prove that for the cardioids r equal to a times of 1 plus cos theta, as rho square by r is constant. Consider the given curve r equal to a times of 1 plus cos theta. So taking log on both the side, apply the laws of logarithm in the right hand side, then differentiate this with respect to theta. I got 1 over r into dr by d theta. Derivative of log a is constant, 0. Derivative of log of 1 plus cos theta is 1 by 1 plus cos theta into derivative of cos theta is minus sin theta. So as I discussed in the previous video, we can apply the trigonometric identities, and I will get back with the solution as minus tan theta by 2. Minus tan theta by 2. Therefore, dr by d theta is r1. r1 equal to, transfer this r to right hand side. So minus r tan theta by 2. This is what r1. Differentiate this with respect to theta, you are going to get r2. So I have got established r2. r2 as minus r by 2 times of secant square theta by 2 plus r tan square theta by 2. Now substituting those values in radius of curvature formula of polar form, rho equal to r square plus r1 square whole power 3 by 2 divided by r square plus 2r1 square minus r2. So substituting r value, r1 value, r2 value in the equation. So I am going to get this is the equation. I have just substituted r1, r2 value. I have got these values, and simplifying and applying trigonometric identity, I got 1 plus tan square theta by 2 can be written as secant square theta by 2. Secant square theta by 2 plus 1 by 2 times of secant square theta by 2 will be of 1 plus 1 by 2, 3 by 2. 3 by 2 secant square theta by 2. Here square and square root get cancelled. You are left out with secant cube theta by 2. So here r square get cancelled. You are left out with finally the answer as 2r by 3 times of secant theta by 2. This is the final answer as rho. So name that as star. So from given equation, I am going to find out r as r equal to 2a cos square theta by 2. So from this I am going to establish secant square theta by 2 or secant theta by 2. So I will find out secant theta by 2 as square root of 2a by r. 2a by r. So substituting that value in the star equation, star becomes rho equal to 2 by 3 times of square root of 2ar. Square root of 2ar. Squaring on both the side, I am going to get the answer as rho square by r equal to 8a by 9. So 8a by 9 is a constant. Therefore, as they have asked to shown that rho square by r is constant, I have proved that part. This carries 7 marks. Moving on to question number 2a. Show that the curves r power n equal to a power n cos n theta and r power n equal to b power n sin n theta cuts each other orthogonally. It is nothing but one and the same, finding the angle between two curves. The same procedure. I will apply log on both the side. Taking log on both the side, differentiate with respect to theta. Then if there is any identity, apply that identity. Here there is no need of identity. Sin by cos can be written as tan. Here also got cos by sin as cot. Therefore cot get cancelled. You are left out with phi 2 as n theta. Here you have got minus tan n theta. Minus tan n theta can be written as in terms of cot as cot of pi by 2 plus n theta. Cot get cancelled. Phi 1 is equal to pi by 2 plus n theta. So finding the angle between these two curves, modulus of phi 1 minus phi 2. So here n theta get cancelled. N theta minus n theta get cancelled. You are left out with what? Pi by 2. As I discussed in the previous video, if you get the angle between two curves as pi by 2, we say that the given curves cuts each other orthogonally. So therefore, this given curve cuts each other orthogonally. Next, moving on to question number B, 2b. Find the pedal equation of the curve r power n equal to a power n cos n theta. Consider the given curve r power n equal to a power n cos n theta. Name that as equation star. Taking log on both the side and apply loss of logarithm in the right hand side. So differentiate with respect to theta. I got cot phi equal to minus tan n theta. I told you that in the previous problem, minus tan n theta can be written as cot of pi by 2 plus n theta. Cot get cancelled. Phi equal to pi by 2 plus n theta. As they are asking for pedal equation, so consider the equation p equal to r sin phi. Substitute the value of phi. Phi value is what? Pi by 2 plus n theta. So sin of pi by 2 plus n theta is cos n theta. Now from equation star, I can write cos n theta as r power n by a power n. Substitute that from star. I have substituted that. Bases are same. The numerator here r into r power n. Add the powers of r. We are going to get r power n plus 1 divided by a power n equal to p. Therefore, r power n plus 1 is equal to a power n times of p is the required pedal equation. Moving on to next question. Question number 2c. Find the row for the curve y square equal to a square times of a minus x divided by x at the point a comma 0. So you require to find the radius of curvature for the given point with the given function. So given y equal to 0, so we can establish the value of x as, if they, why I have written this one means, if they don't give the value of x, they will give that the given curve cuts the x-axis. It means y equal to 0. So if they mention like that, you can write that one as y equal to 0 given and find out the value of x. So therefore point of intersection is a comma 0. So consider that curve and differentiate that with respect to x. I got derivative of y square as 2y y1 is equal to minus a cube by x square. So finally y1 value is minus a cube divided by 2x square y. At a comma 0, y1 at a comma 0 will be an infinity here, since if I substitute the value of y as 0, 1 by 0 is nothing but infinity. So I got the value of infinity here, the value of y1 as infinity. Hence I can't substitute in row, so I will take the reciprocal of y1, that becomes x1. So hence x1 will be equal to minus 2x square y by a cube. So x1 at a comma 0 will be an 0 value. Since y equal to 0, 0 by a cube is 0. So I got x cube value, x1 value as 0. So find out x2, differentiate x1 with respect to y. So I will get, this is what x2 I am getting. So here you require to apply a product rule here, x square into y. So x square into derivative of y with respect to y is 1 plus y into derivative of x square is 2x into x with respect to y is x1. So therefore x2 at a comma 0, just substitute the value of x as a and the value of a as y as 0 in the above equation. I will get the answer as minus 2 by a. Then I know the formula for radius of curvature in Cartesian form is 1 plus x1 square whole power 3 by 2 divided by x2. Substituting the value of x1 and x2 in the equation, I got minus a by 2. As the radius of curvature should not be in a negative value, take the modulus sign. So modulus of rho is equal to a by 2. Therefore, I got the rho value as a by 2. This is the required radius of curvature for the given curve. Now moving on to module 2. 3b is given as if u equal to tan inverse y by x, where x and y is given, find the total derivative du by dt using partial differentiation. So here u is depending on x and y is depending on t. Finally you require to find out u depending on t. So that is what total derivative du by dt is defined as del u by del x into dx by dt plus del u by del y into dy by dt. So therefore del u by du by dt is what? Differentiate u partially with respect to x. This is what I am going to get. Partial derivative of tan inverse y by x is 1 by 1 plus y by x the whole square into derivative of y by x partially is minus y by x square into ordinary differentiation of x with respect to t. Derivative of e power t is e power t minus e power minus t derivative is minus e power minus t. So minus into minus plus it will be. So therefore it is e power t plus e power minus t. Similarly, I am going to differentiate u partially with respect to y, treating x as constant. I am going to get 1 by 1 plus y by x whole square into derivative of y is 1, 1 by x is constant, therefore it is 1 by x. That is what I have written. Differentiate y with respect to t ordinary. E power t plus of e power minus t derivative is minus e power minus t. So therefore finally dy by dt is e power t minus e power minus t. Simplifying this term, taking LCM as x square here, denominator, x square get cancelled. I got the value as minus y by x square plus y square into e power t plus e power minus t. Similarly here, x by x square plus y square, e power t minus e power minus t. I have just taken out x square as LCM. Then substituting the values of x and y in the above equation, I got the denominator is same. I have taken the LCM. In place of x, it is e power t minus e power minus t the whole square, plus in place of y, e power t plus e power minus t the whole square. So, and y value is known for us. So, it will be of the form a into a square, plus b into b square I have written. So, expanding this numerator and denominator, I got the answer as minus 2 by e power 2t plus of e power minus 2t. This is the partial derivative of u with respect to t. Now moving on to 4a. Moving on to 4a, it is L'Hopital rule, LH rule. It is very important problems. Limit as x tends to 0, a power x plus x whole power 1 by x. So taking now defining that value as k, if I apply the limit as x tends to 0, a power 0 is 1 plus 0 is 1 plus 0 is 1, power 1 by 0 is infinity. Therefore, I got the form as 1 power infinity form. So when I get 1 power infinity form or 0 power 0 or infinity power 0, we will apply log on both the side, and then we try to get in the form 0 by 0 form or infinity by infinity form. By taking log on both the side, I got the right hand side as log of ax plus x log of a power x plus x whole divided by x. Since log a power m is m log a, m value is 1 by x, that is what I want denominator as taken as x. Now applying again limit here as x tends to 0, a power 0 value is 1 plus x value equal to 0. So 1 plus 0 is 1. Log 1 is 0 divided by as x tends to 0, 0. 0 by 0 form. Now you can apply LH rule. Log k will be equal to limit as x tends to 0, 1 by a power x plus x into derivative of a power x is, keep in your mind, derivative of a power x is a power x log a plus 1. Derivative of x is 1. Whole divided by derivative of x is 1. Now applying limit a power 0 is 1 plus 0, 1 plus 0 is 1, 1 by 1 is 1 into a power 0 is 1 plus log into log a plus 1 we have. So therefore it is a power x 0 is 1 into log a. So therefore it is 1 into log a is log a plus 1. You are left out with log a plus 1 in the right hand side. So therefore taking raising the power by e on both the side, you are going to get k equal to e power log a plus 1. Now considering the second problem in that same question, k equal to limit as x tends to pi by 2 tan x whole power tan 2x. So taking the limit tan pi by 2 is infinity, whole power tan 2 pi by 2, 2 to get cancelled, tan pi value is 0. So therefore it is of the form infinity power 0. There is another problem. It can also be given this limit as pi by 4. This problem can also be defined as pi by 4. Keep in your mind 0. Infinity power 0 you got. This is one of the indeterminate form. So taking log on both the side and applying laws of logarithm in the right hand side. So I am going to get tan 2x into log of tan x. Taking the reciprocal of tan 2x, you are going to get cot 2x. As if you apply the limit as x tends to pi by 2, you are going to get infinity by infinity form. Now apply LH rule on the right hand side, I am going to get derivative of log tan x as 1 by tan x into derivative of tan x is secant square x minus 2 denominator derivative is minus 2 cosecant square 2x. Simplifying this, I am going to get 1 over cosecant can be written as sine square, and I will rewrite tan as sine by cos. I will rewrite secant square as 1 by cos square x. So cos get cancelled. The denominator will be 2 sin x cos x. So 2 sin x cos x is nothing but sin 2x. So one term of sin 2x get cancelled. You are left out with minus limit as x tends to pi by 2 sin 2x. As x tends to pi by 2, the value of sin pi is 0. Therefore, rising by e on both the side, k value is equal to 1. K equal to 1. Now moving on to question number B. For B, if u equal to f of y by x by xy, z minus x by xz, show that x square ux plus y square uy plus z square uz is equal to 0. I will define the function as p equal to y minus x by x by y, xy, q as z minus x by zx. Now, by applying chain rule, del u by del x is defined as del u by del p into del p by del x plus del u by del q into del q by del x. I will find out partial derivative of p with respect to x, treating y and z as constant. So this is what I got. I have applied a quotient rule. This is what I have got. Here minus xy, minus into minus plus xy get cancelled. So you are left out with minus y divided by minus y into y, minus y into y is minus y square divided by x square y square. Here in this part also, while finding del q by del x, I am going to apply partial derivative. So treating yz as constant, I will apply quotient rule. There also I have left out with minus z square divided by x square z square. So in the required result, I need to multiply del u by del x by x square. I am going to multiply by x square del u by del x. I got the value as minus del u by del p minus del u by del q. Name that as equation 1. Similarly, I can find out del u by del y by using chain rule. Then I am going to multiply by y square. So finally I got y square del u by del y as del u by del p. Similarly, z square del u by del z as del u by del q. Name that as equation 2 and 3. Now adding 1, 2 and 3, I got x square ux plus y square uy plus z square uz is equal to 0. This carries 7 marks. Now moving on to question number 4c, find the extreme values of x cube plus y cube minus 3axy where a is positive. They have mentioned that a is positive. So I will consider the given function as f and find out the partial derivative of f with respect to x and f with respect to y. I got f with respect to x as 3x square minus 3ay, fy as 3y square minus 3axy, and equating these two values to 0, I will get the stationary points as 0, 0 and a. Then I will find out a, b, c. I have explained in the previous video what is a, b, c. And I will find out ac minus b square, and I will put these two values 0, 0 and a. I got the table of content like this. As here negative value, I will name this as saddle point. I will give the conclusion as saddle point. Here 6a as taken as positive, since the reason behind that is, since in the given problem a is positive, therefore we can say that 6a will be a positive value, and ac minus b square I got as positive value. When both are positive, I can tell that that point is maximum. So therefore a is a maximum point for the given function. So this carries 7 marks. Now moving on to module 3. Solve dy by dx plus y tan x is equal to y cube secant x. So it is a Bernoulli's differential equation. divide throughout by y cube. I am going to get 1 over y cube dy by dx plus 1 over y square tan x is equal to secant x. I am going with a substitution 1 over y square equal to t, and I will differentiate with respect to x. I got the value as 1 over y cube dy by dx is equal to minus 1 by 2 times of dt by dx. So substituting this value in the above equation, I will get minus 1 by 2 times of dt by dx plus tan x into t, which is equal to secant x. So finally I got an expression dt by dx multiplying throughout by minus 2. I got an expression as dt by dx minus 2 tan xt, 2 tan x into t, which is equal to minus 2 secant x. So the equation is of the form dt by dx plus pt. P is what? Minus 2 tan x, and q is what? Minus 2 secant x. That is what I have defined. So using this p and q, I am going to find out integrating factor. So this is what integrating factor, e power integral of p dx. P is what? Minus 2 tan x dx. So which is equal to integral of tan x is what? Log secant x. So I got minus e power minus 2 log secant x. Applying laws of logarithm, I got e power log of secant power minus 2 x. Then I can write that value as 1 over secant square x, integrating factor. Then the solution is given by t into integrating factor, that is t into 1 by secant square x, which is equal to integral of q into integrating factor. Q is secant to secant x, which is multiplied with secant square x. So here secant get cancelled, secant get cancelled. So you are left out with 1 by cos, 1 by secant. 1 by secant is nothing but cos. So therefore cos x is integral of cos x is sin x. I think here I have left out minus 2. You can write down minus 2 here. So the final answer will be minus 2 sin x plus c. Cos square x divided by y square is equal to minus 2 sin x, minus 2 sin x. Don't forget about correction. I told you that here I have left out with q value as what? Minus 2 secant x. So write down minus 2 secant x. Then multiply each value by minus 2. You are going to get the answer. Then moving on to fifth B, Newton's law of cooling. Water at temperature 10 degrees Celsius takes 5 minutes to warm up to 20 degrees Celsius at a room temperature of 40 degrees Celsius. Find the temperature of the water after 20 minutes. So I will define T1 as 40, T2 as 10 degree, capital T as 20 degree, small t as 5 minutes. After 20 minutes, what is the value? I am going to find out. First, let us find out the value of K by substituting in this standard result. Capital T equal to T2 plus of T1 minus T2 into e power minus KT. So I will get the value of K as, look at, you can go through here. I got K value as 0.21972. So now I will substitute this K value when small t equal to 20 minutes. So I will get the capital T value as 10.37 degrees Celsius. This is what Newton's law of cooling carries 7 marks. Now moving on to question number 5C. It is solvable for looking at the problem only. You should tell it is solvable for P. Don't divide by P. Directly take with common as P square. You are going to get the factors as P square minus y square P and p plus 2x equal to 0. Equating each values to 0, you are going to get, now you can divide by p. You are going to get p minus y square equal to 0, p plus 2x equal to 0. P is nothing but what? Dy by dx equal to y square. Here dy by dx equal to minus 2x. Separate the go with the variable separable and integrating on both the side. You are going to get the general solution as x plus 1 by y plus c1 and y plus x square by c2 equal to 0. This is the required solution for the given differential equation. Moving on to question number 6a. It is exact differential equation. It is of the form m dx plus n dy. Define m and define n. What is m and what is n? Write down. After writing down m and n, differentiate m partially with respect to y, differentiate n partially with respect to x. So the partial derivative of those two I have written. So as it is not equal, we can say that del m by del y is not equal to del n by del x. The given problem is reducible to reducible to exact. So taking the difference of these two, 3y square minus y square, I got 2y square. This value is near to n. This value is near to n, since n contains y square x. So now as I told you that this value is near to n, I will divide this difference by n. I am going to divide this difference by n. Dividing by n, I got the value of 1 by n into del m by del y minus del n by del x as 2 by x, which is nothing but f of x, function of x. Find the integrating factor. Integrating factor is e power integral of f of x dx. E power integral of 2 by x dx is nothing but e power 2 log x, which is equal to x square. Multiplying this x square in m and n, I am going to get m as x power 4 plus y cube x square plus 6x cube and n as y square x cube. Then differentiating partially m with respect to y and n with respect to x, I got both are one and the same, so which is reducible to exact. Now the solution of this is integral of m dx plus integral of n of y dy equal to c. I have told you that n of y means the terms containing y alone. As there is no term containing y alone in n, so we will consider that as 0. I will consider whatever the value m, I have written that m, and integrated with respect to x. So I got x power 5 plus y cube, x cube by 3 plus 3 by 2 x power 4, which is equal to c, is the required solution for the given differential equation. So next move on to self-orthogonal. It is a very important problem. Prove that the system of parabolas y square equal to 4a times of x plus a are self-orthogonal. Consider the given curve and name that as equation star and differentiate that with respect to x. I got 2y into dy by dx is equal to 4a times of 1, which is nothing but 4a. So therefore I will find out the value of a equal to y1 divided by 2. Substituting this value in equation star, I can eliminate the value of a, that is my aim. So after elimination, I got the equation star as y equal to 2x y1 plus y1 square. I will name that as equation 1. So, and I will say that this is the D of the given family. Now after coming to know that finding the differential equation for the given curve, now replace y1 by minus 1 over y1 in equation 1. I got y as minus 2x by y1 plus y by y1 square, and multiplying throughout by y1 square, I am going to get y1 square plus 2x y1 equal to 1 equal to y, and name that as equation as 2. Now comparing this equation with equation 1, so which is nothing but left hand side is nothing but right hand side, and right hand side is nothing but left hand side. Therefore I can say that as both the differential equations are one and the same, we conclude that the result is self-orthogonal. Self-orthogonal. Moving on to question number 6c. Find the general solution and a singular solution of the given problem. So now I will take the terms of y to the right hand side, and I will rewrite this expression as xp square plus px plus 1, which is equal to y times of p plus 1. Then I will define y. What is y? Y is nothing but px plus 1 over p plus 1. Now I will name that as equation 1. You may have a doubt that why we have done like this. As looking at the problem, we should know that this problem is of Clairaut's equation. So now the problem has been reduced to the form of Clairaut's. It is y equal to px plus f of p, function of p. Then the solution, general solution, is given by just replace p by c. You are going to get the general solution, y equal to cx plus 1 over c plus 1. This is what general solution. To find the singular solution, we are going to eliminate the value of c. So to eliminate value of c, I am going to differentiate with respect to c this equation. So differentiating this with respect to c, I am going to get treating the remaining variables as constant. 0 equal to x minus 1 by c plus 1 the whole square. Finally c equal to 1 over square root of x minus 1. Substituting this value in the general equation, general solution, I am going to get y equal to root x minus x plus root x. So which is nothing but 2 root x minus x. So therefore singular solution is nothing but x plus y the whole square is equal to 4x. Nothing to worry here. Just I have moved minus x to left hand side, it becomes y plus x or x plus y, and then squaring on both the side, y x plus y whole square is equal to 2 root 2 whole square is nothing but 4x. That is what the solution I have got. This is what singular solution, and this is what general solution. When they ask to find singular solution and general solution, this is the way of finding the singular solution and general solution. Moving on to question number 7, that is of module 4, which is easiest module 4 and module 5. So here they have given the differential equation 4d power 4 minus 8 d cube minus 7d square plus 11d plus 6 on y equal to 0. Once you came to know that it is 0, it is an homogeneous differential equation. Just find out yc. So consider the given equation as auxiliary equation. So find the roots of that equation. As the degree of this equation is 4, by inspection I am going to find one of the root. So by inspection I got a root as m equal to minus 1. So by using m equal to minus 1, I will go with synthetic division. I got the equation has been reduced to 4m cube minus 12m square plus 5m plus 6 equal to 0. Solving this by using your calculator, you will get the roots as 2 minus 1 by 2, 3 by 2. Therefore, the roots are minus 1. Don't forget about minus 1. My dear friends, don't forget this root. I know that you will forget. Don't forget this root. You never forget this root. So, find as the given the given differential equation is of degree 4, you should have 4 roots. So, therefore, m equal to 2 minus 1, 2, minus 1 by 2, 3 by 2. The roots of the equations are minus 1, 2, minus 1 by 2, 3 by 2. So, therefore, the solution is y equal to c1 e power minus x plus c2 e power 2x plus c3 e power minus x by 2 plus c4 e power 3x by 2. This is the solution. Moving on to question number 7th B. Solve d square y by dx square plus dy by dx equal to x square plus 2x plus 4 of type 3. Consider the auxiliary equation. Auxiliary equation is of the form m square plus m equal to 0. The roots of that equation is 0 and minus 1. As the degree is 2, you should have 2 roots. Therefore, the yc is c1 plus c2 e power minus x. Then yp is given by polynomial divided by function of d. Rearrange this form. Numerator should be decreasing powers of x, I have arranged, and denominator should be increasing powers of d. D plus d square, I have arranged. Then go with division method. By division method, I will get the answer as x cube by 3 plus 4x. Very simple problem. X cube by 3 plus 4x. So finally, the general solution is given by y equal to yc plus yp. Adding yc value and yp value, that will be the solution. Next, moving on to question number 7c of variation of parameters. The given problem is solve d square y by dx square minus 6 dy by dx plus 9y is equal to e power 3x divided by x square. Consider the auxiliary equation of the given differential equation. It is of m square minus 6m plus 9. Solve this equation, I am going to get the roots of that equation as 3 comma 3. Write the solution. C1 plus C2x e power 3x. I will multiply e power 3x inside. I will get C1 e power 3x plus C2 x e power 3x, and I will consider the general solution as y equal to a e power 3x plus b x e power 3x. I will name this as equation star, and I am going to find out the value of a and b, and naming y1 and y2 as y1 as e power 3x, y2 as x e power 3x. I'll find out y1 dash, y2 dash. Then I will find out Wronskian. Wronskian is given by y1, y2 dash minus y2, y1 dash. So by multiplying this, and I will get Wronskian as e power 6x. How we got? E power 3x is multiplied with this expression. So e power 3x into 3x e power 3x. Bases are same, add the powers. So it is 3x e power 6x. 3x plus 3x is 6x. Plus similarly e power 6x minus x e power 3x into 3 e power 3x. It will be minus 3x e power 6x. So therefore plus 3x e power 6x minus 3x e power 6x get cancelled. You are left out with e power 6x. And by looking at the right hand side of the given differential equation, we define phi of x as e power 3x divided by x square. Now let us find out the values of a and b. As we know that the standard formula of a is minus integral of integral of y2 phi of x divided by Wronskian with respect to x. B is given by integral of y1 phi of x divided by Wronskian with respect to x. Substitute these values of y2 phi of x and Wronskian. Simplify that part. I will get integrand as 1 by x. Integral of 1 by x is log x. So similarly go for finding b. I got the value of b as minus 1 by x plus k2. So now substituting the values of a and b in equation star, I will get the solution as y equal to k1 plus k2 x e power 3x minus e power 3x log x minus e power 3x. So this carries 7 marks. Now moving on to question number 8a. Solve the differential equation of type 1 e power ax we have. Find out the roots of the equation. As it is cubic roots, you are going to get repeated roots. Be careful. In your calculator, you will get the answer as 3 and 1. Only x1 as 3 and x2 as 1. So 1 can be taken as repeated roots. Therefore 1 comma 1, 3 comma. So therefore the solution is yc is c1 plus c2 x e power x plus c3 e power 3x. Yp is what? E power 2x divided by function of d. Function of d is nothing but this is 1. The left hand side of given differential equation. Just replace d by 2. I am going to get e power 2x divided by minus 1. Adding yc and yp, that will be the required result for the given differential equation. This carries 6 marks. Moving on to question number 8b. Solve d square y by dx square plus 4 dy by dx plus 3y equal to sin x. It is of type 2. Trigonometric function is of type 2. So find the auxiliary equation and find the roots of the auxiliary equation. I got the roots of the equation as minus 1, minus 3. So yc is equal to c1 e power minus x plus c2 e power minus 3x. And yp is sin x divided by d square plus 4d plus 3. Replace d square by minus 1. Since a value is 1 here, replace d square by minus 1 square. That becomes 1 square is nothing but 1. In the place of my d square, I am going to replace the value as what? Minus 1. So minus 1 plus 3 is what? Plus 2. So the denominator will be 4d plus 2. This is what? 4d plus 2. Now rationalize the denominator. Since the problem will be of the form sin ex divided by f of d. It is not in the standard form. It should be f of d square. To make sure that I am going to multiply and divide by 4d minus 2 divided by 4d minus 2, and in the numerator I am going to multiply by sin x for these two values. 4 into derivative of sin x is cos x, 4 cos x minus 2 sin x divided by 4d into 4d is 16d square minus 2 into 2, 2 square, that is 4. Replacing d square by minus 1, that value will be minus 20. Then divide by minus 20 each of numerator. I am going to get minus by minus get cancelled. So 2 by 20 is 1 by 10 sin x by 10 minus 4 by 20 is 1 by 5. So therefore it is cos x by 5. So adding yc and yp, that will be the required result. If you forget to write down yc plus yp finally here, you are going to lose 1 mark. Don't forget to write down yc and yp. My dear friends, no one should forget writing yc and yp. Though you have represented yc and yp, it is not understood that you have written the answer. The final answer should be written in terms of sum of those two, yc and yp. Moving on to question number 8c. It is of Lagrange's differential equation. So 1 plus x square d square y by dx square plus of 1 plus x dy by dx plus y equal to sine of 2 log of 1 plus x. Go with the standard substitution, t equal to log of 1 plus x. Then rising by e on both the side, I am going to get e power t equal to 1 plus x. Now the substitution will be 1 plus x y dash will be as what? 1 into dy, and 1 plus x square y double dash will be 1 square into d minus 1 on y. So substituting these two values in the given equation, so I am going to get equation as d square plus 1 on y is equal to sine 2t. So write down the auxiliary equation, find the roots of that auxiliary equation is plus or minus I. Write down yc equal to c1 cos t. Don't forget here writing as t here. Don't write x here, since we have substituted t in terms of x. T is in terms of x. Therefore c1 cos t plus c2 sin t. Go with yp. Yp equal to sin 2t divided by d square plus 1. Replace, as it is type 2, replace d square by minus a square. Here a value is what? 2 minus 4 it will be. So minus 4 plus 1 is what? Minus 3. The final answer is minus sin 2t divided by 3. So sum of these two, yc plus yp, have written here. Then I am defining t. T is what? Log of 1 plus x. If you not define t here, you are going to lose 1 mark out of 7 marks. So moving on to last module, my dear friends. We are at the end of the module 5. Find the rank of the matrix. Now in the given problem, the leading entry itself was 0. Always the leading entry should be non-zero. To make sure that non-zero, I am going to interchange R1 and R2. That is what the first operation I have done. When we should do the interchange of first row, this is the main thing you should know. As it is 0 here, make sure this term as non-zero. To make sure that value is non-zero, I am just interchanging with R2. So that is what row 2 has been changed with row 1. So therefore, then I will make sure the 3 and 1 as 0 by using R1. So this is what operation, R3 minus 3 times of R1, R4 minus R1 I have done, and then I got R3 and R4 as new row. Now my aim is to make sure these two values as 0 by using R2. I have applied that operation. So R3 changes to R3 minus R2, R4 changes to R4 minus R2. By doing this, R3 and R4 get vanishes. So the non-vanishing row is R1 and R2. Therefore, the number of non-zero rows are 2 rows. Therefore, we can say that the rank of the matrix is 2. The rank of the matrix is 2. Next, moving on to the solution of system of equation by Gauss elimination method. I will write the augmented matrix first. What is augmented matrix? Augmented matrix A is nothing but a coefficient matrix, that is 3, 1, 2. Similarly 2 minus 3 minus 1, 1, 2, 1. That is what I have written here. And this is what column matrix B. that is constants 3 minus 3 4. Now I am going to, as they have asked for Gauss elimination method, you are required to find out upper triangular matrix. I am going to find out upper triangular matrix. I will make sure these two terms 2 and 1 as 0 by using R1. That is the operation I have done. 3R2 minus 2R1, 3R3 minus R1. So by doing that, I got this matrix. Then now I will make this value 5 as 0 by using R2, by using only R2. So I got that new matrix. This is the new matrix I got. Now I will rewrite the given whatever the equation matrix I got. In terms of equation I am going to write. It is 3x plus y plus 2z plus equal to 3 minus 11y plus minus 7z equal to minus 15 minus 24z equal to 24. By solving this, I got z value as minus 1. Substituting that z value as minus 1 in the second equation, I will get the value of y as 2. Substituting z value and y value in first equation, I will get the value of x as 1. Therefore, the solution of the equation is x equal to 1, y equal to 2, z equal to minus 1. Now moving on to question number 9c. Using Gauss-Seidel iteration method, solve the system of equation. Carry out 4 iterations starting with the initial approximation 0, 0, 0. As I observed that the given system of equation is not diagonally dominant, so I will rearrange the equation first. I will retain the first equation as it is, since 83 is greater than sum of 11 and 4. Similarly, when I observe the last equation, 52 is greater than 7 and 13. So I will write down that as second equation. If I observe this second equation, I will retain that as third equation. Now the system of equation has been diagonally dominant. I can rewrite the equation of x, y, z as so and so like this. I have written x, y, z. Now applying the initial condition x, y, z as 0, 0, I got x1 value, y1 value, z1 value, x2, y2, z2, x3, y3, z3, x4, y4, z4. As they have asked for 4 iteration, I went with 4 iteration. Finally, I got the values of x, y, z as x as 1.05176, y as 1.36719, z as 1.96171. This is the solution for the required result. Moving on to last question of this module, 10th A. Test for consistency and solve. So write down the augmented matrix. Go for finding the upper triangular matrix. By doing that, I got the last row as 0 row. So I came to know the rank of matrix A is 2 and rank of augment matrix is also 2. Therefore, I will define that as rank A equal to rank of augment matrix is 2, which is less than 3. 3 means what? X, Y, Z. That is what? Unknowns. So 2, the value rank 2 is less than number of unknowns. Then the solution is defined as infinite solution. I will rewrite the given system of equation as 5x plus 3y plus 7z equal to 4. Here dividing by 11, I got 11y minus 1z equal to 3. That is what I have written. Now I am going to assume that z is some arbitrary constant as k, z equal to k. Substituting that value z equal to k in the above equation, I will get the value of y as 3 plus k by 11. Substituting y value and z value in equation 1 here. So I am going to get x as 7 minus 16k by 11. So this is the infinite number of solution for the given system of equation. So this carries 6 marks. So now moving on to question number 10th B. Using Gauss-Jordan method, solve the system of equation. Write down the augmented matrix. So the augmented matrix is 1, 1, 1, 1. is to 11, 3 minus 1, 2 is to 12, 2, 1 minus 1, 3. Now I will make sure these two values as 0 first. I have done that part, 0. I have applied the operation for throughout the row. Now I will make sure whatever the round off part I have done here, make sure these terms as 0 using R2. This is what the operation I have done. I have written here 4R1 plus R2, 4R3 minus R2. So I will got this equation. Then I will divide R3 by minus 11. So therefore I got 1001 is to 5. Now I am going to find out, I make sure the value called 3 and minus 1 as 0 by making the operation R1 minus 3 times of R3, R2 as R2 plus R3. So by using that I got the matrix as like this. Now I will rewrite this in terms of equation as 4x equal to 8 minus 4y equal to minus 16, z equal to 5. So therefore from this I got the solution as x equal to 2, y equal to 4 and z equal to 5. This is the solution using Gauss-Jordan method. Finally, moving on to last question, that is eigenvalues and eigenvectors. For the given matrix, you are required to find out the largest eigenvalue and largest eigenvector using the initial eigenvector as 1, 0, 0. If they don't mention 1, 0, 0, you can consider 1, 1, 1 or 1, 0, 1, whatever you want, you can consider. And finally, it should match with the previous vector. Then you can finalize the answer. So by using Ax upon 0, I got the matrix as like this. 6 minus 2, 2. Here the largest value is 6. Divide this by matrix by 6. I got as lambda 1 and x1. Similarly, I got lambda 2, x2. By just multiplying x1 value with a, I got lambda 2, x2. Now multiplying x2 value with a, I will got lambda 3, x3. Similarly, I will got lambda 4, x4, lambda 5, x5, lambda 6, x6. So this is the largest eigen value called 7.997, or you can write approximately 8, and the eigenvector as 1.5 minus 0.5 minus 0.5 is the largest eigenvector for the given matrix. Friends, I thank you all for watching this video. If you like this video, kindly do subscribe to my channel, and if you have any doubts, kindly put a comment. I will clear your doubts. As you have still time for study, do well for your examination. All the best, my dear students. All the best, my dear friends. All the best. Take care.